All right, class, let's talk more about normal distributions. Let's take a look at the following example. The miles per gallon of a Jeep Compass on the highway, let's see, average miles per gallon is 32 approximately, with a standard deviation of 2. So mu equals 32 and sigma equals 2. Here's my question. What probability or what percent of Jeeps average a miles per gallon between 31 to 35? So we want to know what's the probability we're between 31 to 35. So I'm going to write probability 31 is less than x is less than 35. I'd like to know what percent of those, or probability, lie between 31 and 35. All right, so I have my normal distribution here because we're going to say that Jeeps, which are manufactured, will have a miles per gallon distribution that is approximately normal. So if 32 is in the middle and we're 2 standard deviations away, we've got 32, 30, 28, and 26. Then on the other side, we have 34, and then 2 more is 36, and 2 more is 38. So we want to go from 31, which is right here, from 31 all the way to 35. So we like to know what percent go between a 31 and a 35. So we're going to shade that in. So we want to find that area. Well, we've learned before you can use z-scores to find the area to the left of it based on our charts. Here's our issue. We don't have an in-between chart. So what we'll do is we'll figure out 2 values. We're going to figure out the smaller one first, and then we're going to figure out the larger one second. The larger one, the smaller one. Larger, which is all of this, minus the smaller, gives us what's in between. So larger minus smaller, or the right-handed one minus the left-handed one. We subtract those 2, we'll get what is in between. All right, so we need to do a z-score for a 31. So let's do that first. So a z-score for a 31 equals, let's remember our formula. Z equals x minus mu over sigma. So our x this time is a 31 minus our mean of 32 all over our standard deviation of 2. So that z-score is, let's see, 31 minus 32 is negative 1 over 2 is negative 1/2, or negative 0.5. So that's what represents this value right here. On our z-scale, negative 0.5. And that's right, it's between 0 and negative 1, negative 0.5. Now let's find the z-score for a 35. That's this one right here for a 35. It's probably going to be 1.5. It's between 1 and 2. So it's 35, because that goes in for x, minus the mean of 32, all over a standard deviation of 2. So that's going to be 3 over 2, which is 1.5. So that z-score is a 1.5. So that value is, that makes sense, a 1.5. Now we need to change some things up here. All right, I'm going to rewrite this in z notation. So now the problem mathematically becomes, what's the probability that z is between negative 0.5, I'm going to use a z this time, and a positive 1.5. So that represents this whole shaded area right there. All right, so we're going to find 2 separate ones. We're going to find the probability for negative 0.5, so that's going to give us this much. That's going to give us that area. And then we're going to find the probability of 1.5, and that's going to give us all of that. So we'll take the larger minus the smaller, and it gives us what's in between. Okay? Think about that. Here's our larger one. Let's superimpose impose that smaller right on top of that. The larger minus the smaller gives us what's left right there, what's in between. So using your charts, we're going to look those up. All right, so we have two different charts. We have one chart that looks like, and I'm going to erase these now. We have one chart at the very bottom. The sketch looks like this. It's a left-handed chart, a left side of mu. And the other one is larger. It's everything that's right of the zero, right of mu. So all the negatives are the smaller one, all the positives, which are on the other side of zero, are the larger one, or the other side of mu. So if I look up negative 0.5 on my chart, all right, and what are we looking up? We are looking up for negative 0.5 on my chart, negative 0.5, and then my next decimal is a 0. So when I look those two up, I end up with 0.3085. 0.3085. So that's what that area is, or that's what that probability is. 0.3085. See if you can do that on your chart. If you forgot your handout, I have it listed in Canvas, but it's also in the back of your book. For my second one, we want to do 1.5. So with this one, we're going to look up on our chart 1.5, and the decimal would have to be a 0. All right, the second decimal is a 0. So we're going to look up 1.50, and that number should be pretty large. We're over halfway, right? We're over halfway. We're out there in the 80s or 90s when it comes to percent. That is 0.9332. 0.9332. So that represents all of this, 0.9332. All right, so the larger area is 0.9332, and the smaller area is 0.3085. All right, 0.3085, 0.9332. If I subtract the 0.3085 from 0.9332, we get what's in between. So let's do that. So 0.9332 minus 0.3085, and our total answer is 0.6247. So that decimal you can make as a percent, and that answer is 62.47% of those Jeeps have a mile per gallon of 31 to 35. All right, so what do? We converted the z-scores first. This time we had 2 of them. We found the area to the left for the smaller one. We found the area to the right for the larger one, based on those charts. And then we did what? We subtracted the 2. Next up, let's do a little backwards problem. And let's say that in our class of statistics, our average at the end of the semester is a 70. But the university policy says that anybody in the bottom 10%, must retake the class. Okay? So what does that mean as a sketch? What does bottom 10% look like? Well, that'd be the left side. So these people right here, that's 10% of students. Here's 90% of students. The mean's right in the middle. All right, so here's what we know about our class. We know that in my class, we'll say the average ended up being a 70. Yours will be much higher. And our standard deviation for that class is a 6. So the question is, what score is that divides the bottom 10% of the class? So we're going to do a z-score again. Remember, z equals our observation minus mu over 6. What we're looking for this time is this value. Whoops, I put a 6. I want to put a sigma in that spot. We're looking for that value. So we're going to find the z-score first from our chart. We're going to put a number right in there. We know that number is a 70, and we know the standard deviation is a 6. And then we'll do some math and get the rest. Okay, so here we go. Using my chart, this is what we have to do. we've got to search all the numbers in the middle here. And we know it's going to be a left-sided chart because we know what's on the left side. We're going to search all of those numbers until we find the number closest to 0.100 because that would be 10%. So we're going to look for 0.1000. And the closest one we have to that matches negative 1.28. All right, and that number was let's see, from the back of the book. I think it's 0.1003, if you can find that. Okay, so look up on your chart, negative 1.208. You find the number that is the closest. So that z-score, if you put those numbers together, negative 1.28. That's our result, negative 1.28. See if you can find that on your chart. But that's the z-score that has a probability on the left of 0.1003. Okay, that's the closest thing we have to 0.10. All right, if you had it software on your computer, you can actually figure it out exactly. But from our charts, that's what we get. So I'm going to put that in for z. I'm going to put a 70 in for mu and a 6 in for sigma. All right, so let's do that next. So we now have a z-score for this problem. It's negative 1.28. I don't know x. That's that score I want to know, that those students below that score have to retake the class. Mu is 70 and sigma is 6. So now we're going to do a little algebra, right? 6 needs to go over. Right now it's being divided. So we're going to multiply both sides by 6. So negative 1.28 times 6 is negative 7.08. So the 6 went over there. All right, if you remember algebra, you're going to multiply by 6 on both sides. Now I'm going to add 70 to both sides. When I add 70 to both sides, I'm going to get a 62.32. And that's our value for x. So anybody that scores below a 62.32 would have to retake the class based on this information. Okay, that's the bottom 10%. You could, if you put as your answer 62, that's fine. But technically, because you know you can get a decimal score in a class, 62.32 is that number for the bottom 10%. So anything below that is in the bottom 10%. Anything above that is in the top 90%, right? 10% here, 90% over there. All right, so that's all we have with normal distributions. Our next video will deal with the central limit theorem.